Okay, generally, let's see what is the procedure to balance the combustion parameter of the engine using PMI offline system. First step is to take the combustion parameter to check the power delivery by the engine, real power delivery by the engine. As I said, this PMI offline, so the power is not available continuously like in PMI system. In the PMI system, we are taking combustion test parameter and we are evaluate real engine power. With the real engine power, we will be used to balance the estimated engine power. As I said earlier, the estimated power must not be deviate plus minus 2% from real engine load. So we can balance the estimated power calculated by the engine control system by changing the applied fuel quality offset until the deviation between these two power, it will be within 2%. After we balance the power, estimated power is required to take a new set of combustion test parameter, and we are evaluating peak compression of combustion units. We notice first step, as I said, is required to balance the power. In this drawing, we note in this slide, we notice that the estimated power is 57%, while the actual engine power is 49%. The deviation is around 8%. Look to this note, too high deviation between the internal load, so internal load, and the external load, it will influence cylinder lubrication. What we discussed, actual load is 49, real load is 57. So now the engine will be over lubricated. It will lead to the polish of the liner. It will affect the engine performance, load, and scavenge limiter. So we need to correct the estimated power in order to now have an appropriate timing for the combustion calculated by the engine control system based on the estimated engine load. After we balance the power by changing the applied fuel quality offset, we are taking a new set of combustion test parameter and we are evaluating the parameter which will describe the combustion, peak compression, indicated pressure, and Pmax. We can see this parameter of the combustion in these graphs with different color. Peak compression described with green color, Pmax with blue, indicated pressure with red. For a good balancing of the engine is required that the peak compression to not deviate plus minus 3 bar from mean value of the units. So is the peak compression balance within the tolerance of 3 bar, and we notice that all the units are within the mean value. The mean value, it's 96 bar, and we notice that all the units, this engine have 12 units, mainly are within the allowable range. We see in the next slide several reasons which are leading to deviation in the peak compression, mainly the blow by in the exhaust valve, wear piston ring, stuffing box blow by, or piston with increased wear, or cylinder liner. Whatever a small deviation in the peak compression can be compensated by adjusting timing of the closing time of the exhaust valve. So by early closing of the exhaust valve, the peak compression can be increased. But by delaying closing of the exhaust valve, peak compression can be reduced. Gentlemen, we have the opportunity to balance the peak compression by uploading an offset value for unit which is deviating from mean value. On MOP, we have this area on which we can access the respective unit on the button to upload an offset value. But is required to identify the value of the offset in such a way to balance the peak compression. So how we can identify the value? We are evaluating what is the value which is required to be correct. In our example, we notice even the peak compression is all well balanced. For the teaching process, let's reduce the peak compression of unit number 7. we notice that unit number 7, it's operating with 1.7 peak compression increase compared with mean value. So I need to decrease 1.7 bar peak compression of unit number 7. For this is required to identify the offset value to apply on MOP. We have a formula to identify this offset value, peak compression offset unit number 7 is equal with value which must be corrected, divided, reported to the scavenge pressure, corrected to the absolute value. So how I need to balance, how I need to correct? I need to decrease 1.7 bar. I need to decrease 1.7 bar. So minus 1.7. What is the peak compression during the combustion test performance? 1.77 bar. Correct to absolute value. So in order to decrease 1.7 bar peak compression of unit number 7, I need to upload on MOP the value minus 0.6. So now I am accessing the MOP. Allow me to access the MOP. Okay, I have the wait a while. So you notice on process adjustment, cylinder pressure, I have an area where I need to upload an offset value to balance peak compression. As I said, I need to reduce 1.7 peak compression of unit number 7. On my simulator, I have just 6 units. But for the sake of exercise, let's balance the unit number 1. So I need to decrease peak compression of unit number 1.7 bar. For this, I identify the offset value minus 0.6. So I access the button, which is balance the unit number 1. Using the arrow, I upload the respective offset value identified by applying the formula. Okay, you notice now this offset value was uploaded on MOP. The minimum maximum value of the offset value is within minus 2 plus 2. If based on our calculation, this offset value, it will exceed minimum maximum value, this means that the deviation in the peak compression cannot be balanced by changing closing time, by adjusting closing time of the exhaust valve. The wear in the mechanical equipment it's increased and cannot be compensated by changing closing time, by adjusting closing time of the exhaust valve. These buttons, it will allow me to balance the peak compression of each unit, individual unit. But I have this button which will allow me to balance the peak compression mean, so peak compression average, toward the optimal one. So gentlemen, where I can identify peak compression optimal? On process information, for 58% engine load, peak compression, it must be 121 bar. So this is the optimal peak compression for 58% engine load. Let's see how much is the actual peak compression. Optimal was, I don't know, this 121 bar. Let's see how much is the actual peak compression at 58% engine load. We notice now the power was balanced, 57, here I have 58. Peak compression, it's 118.4 real, 118.4. 118.4 bar It's actual peak compression. So gentlemen, now my engine is operating with 2.6 bar reduced than optimal one. In order to compensate this reduced peak compression, I need to increase the consumption fuel oil. So now the engine is not operating optimal. I want to compensate this reduced peak compression. How I compensate? I will identify an offset value, which will be uploaded on this button. So closing time of the exhaust valve, it will be advanced for all the units. But how much is the value which I upload here? I need to identify. So peak compression, mean value, so for all the units, mean value is the value which I want to compensate. So I need to increase from 118.4 to 121. So I need to increase 2.6 bar. So 2.6 divide to the scavenge pressure. Let's see how much is the scavenge pressure. I have scavenge pressure here somewhere. No, I have in MOP. Wait a while. Scavenge pressure 179, so 1.8. 1.8 plus 1, I correct to absolute value. So it's 2.6 divide 2.8. Gentlemen, this is almost 1, 0.9. Is it clear? So
yes, clear.
In order to increase 2.6 bar peak compression, I need to upload on MOP 0.9 bar. So what I'm doing now, I access the MOP, process adjustment. This button, it will compensate for all of them. As I said, the compensation is 0.9. And I press apply. We'll wait a while to see if now the real peak compression it's increasing to the value optimal, which was 121 bar. Okay, I will access again now the PMI system. And let's see if we have any changes. Gentlemen, earlier the value here was 180.4 bar. You notice now the peak compression, it's 122.3. Of course, it's require a little bit to wait to stabilize the engine running. You notice now it's 122.4. It will require a little bit to stabilize the engine running condition, but soon you will see that the peak compression, it will go to match the optimal one based on the correction which was uploaded by us. You notice now start to reduce, it's 122.1. So probably sooner or later it will match 121.7. So as I said, easily the peak compression, it will match the 121.6 now. So you see that during the engine running, this it will start to be adjusted automatically toward the optimal value. Okay. After we balance peak compression using PMI offline, is required to take a new combustion test parameter and to evaluate another type of combustion parameter. Let me see what we are evaluating. I think we are evaluating indicated pressure, yeah? For a well balancing of engine, is required that engine units to not deviate plus minus 0.5 bar from mean value. Indicated pressure is described with red bar graph. There are plenty of units which are deviating. Gentlemen, we notice the unit which is deviate highly, this means that we have increased wear for that unit in mainly in the injection equipment. So if the peak compression is well adjusted, so we adjust a peak compression already. If we have deviation indicated pressure, mainly the reason is that we have faulty injection equipment like fuel valve or fuel pump, fuel booster pump. Small wear in the injection equipment can be balanced by changing the fuel index, by adjusting the fuel index. So to increase the indicated pressure, we give more fuel, or to reduce, we reduce the quantity of the fuel oil, we reduce the fuel index. We have on MOP a cylinder load menu where we can adjust, where we can input an offset value to balance the indicated pressure, but the balancing of the indicated pressure, it will make on two different engine load. If the combustion test parameter was done in engine low load, so below 50%, we balance the fuel index on lower scale. If the performance test was done in high engine load above 50%, the adjustment of the indicated pressure, it will be realized on high load offset area. Same like in peak compression, is required to identify an offset value which will assume that it will balance the indicated pressure. So let's see how we identify this offset value. In our case, is required to reduce the indicated pressure of unit number 4, 0.5 bar, is required to reduce 0.5 bar from actual value. So let's see what will be the value of offset. So PI offset unit number 4, it's equal with the value of indicated pressure of the unit number 4, which must be compensated, divide with the PI mean, multiply with 100. So it's adjustment is in percentage of the fuel index. How much is required to compensate, to correct, to decrease 0.5 bar? So minus 0.5. What is the value of the indicated pressure mean? 12.5. Multiply with 100. So to reduce 0.5 bar indicated pressure of unit number 4 is required to upload on MOP the value minus 4. Okay, based on this calculation, you notice minus 4%. Now, I will access again the MOP. Cylinder load, but on which scale I upload the correction factor minus 4. So let's see how much was the engine load during test performance. During combustion test performance, the engine load was 49%. So engine was operating low load. This means that this correction factor on unit number 4, it will be uploaded on low offset area, minus 4. So now I expect that the indicated pressure of unit number 4 to be reduced 0.5 bar. Gentlemen, if you notice, maximum minimum percentage is minus 5 plus 5 in low load, minus 10 plus 10% in high load. Is based on our calculation. The offset value, it will increase or decrease more than a maximum value. This means that the wear in the injection equipment cannot be compensated by changing fuel index of the engine. I will make a note. It's a common wrong practice in the shipping industry to balance the engine based on the exhaust gas temperature. So also I make this mistake. Sometimes I notice that I have some deviation, high deviation in exhaust gas temperature, and I start to adjust the fuel rack especially on 4-stroke engine, on auxiliary engine, diesel auxiliary engine. In order to compensate or to adjust a little bit the engine, I just adjust the fuel rack. By adjusting the fuel rack, what we are doing? We are adjusting the indicated pressure. We are adjusting the fuel index. So we are increasing the indicated pressure based on the exhaust gas temperature. This will lead to increased torsional vibration from the crankshaft. This is a common mistake in shipping industry. Never adjust the exhaust gas temperature by adjusting, or never adjust the fuel rack in order to have good reading of the exhaust gas temperature. The exhaust gas temperature is a reading which is monitor the mechanical condition of the fuel valve and exhaust valves. Okay, so never adjust the fuel rack in order to have good exhaust gas temperature. Otherwise, you will unbalance the indicated pressure, which will lead to increase torsional vibration of your engine. Is it clear?
Yes, clear.
Clear.
Good. After we balance the indicated pressure, we take a new combustion test parameter, and we are evaluating we will evaluate the Pmax of the engine. Pmax is described in this bar graph with blue in this slide with blue bar graph, and we notice that multiple units which are deviating. Generally, by adjust Pmax, we are changing the timing of the fuel injection. To increase the Pmax, we are advancing the timing of the fuel injection. To decrease the Pmax, we are delaying the timing of the fuel injection. It's the same timing adjustment like VIT, variable injection timing on camshaft control engine. The reason of the deviation, more than 3 bar between the units compared with mean value, mainly also is due by the failure in the fuel injection equipment. So peak compression, Pmax, well engine adjustment, the units must not deviate more than 3 bar. Indicated pressure, the unit must not deviate more than plus minus 0.5 bar from mean values. We notice that there are multiple units which are deviating. Gentlemen, to adjust the Pmax, the value which is deviating is direct upload on the MOP. So the offset value, it's equal with the value which is deviating. We don't have any calculation to be done. I noticed that the unit number 1, it's operating with a Pmax reduced 7 bar compared with mean value. So in order to increase the Pmax of unit number 1, 7 bar, I will access cylinder pressure from process adjustment. And the value which is deviating, it will be direct upload here. So I need to increase 7 bar. So I will upload plus 7. Is it clear? Good. So I have an area where can I upload an offset value equal with the value which is deviated direct to compensate each unit. But I have also a button here which will allow me to balance the Pmax mean value to our optimal one, where I can see the optimal value. For 58% engine load, maximum pressure must be 144 bars. Let's see how much is the actual real pressure, Pmax pressure. So optimal it's 144 bar. 144. Actual it's 153. So my engine is operating with increase 153. My engine is operating with increase 9 bar compared with optimal one. This is leading to increased NOxes. Gentlemen, I can reduce the Pmax of all mean unit, by accessing the value, offset value direct here. So I need to reduce minus 9 bar. I will apply this value. So earlier the value was 153. Let's see if now we have any changes. Minus 9. Earlier was 153. Let's see now what it will be the change. So now you notice it's 143, okay, 144 bars. So we reach the Pmax toward the optimal one. Clear? 144.7. So we reach the Pmax toward the optimal one calculated by the engine control system. What else? Gentlemen, by adjusting the Pmax in low load engine operation, during the engine operation in high load, can do to over increase Pmax pressure. MN is recommend that whenever you make the adjustment of the engine, balancing of the engine, to be performed at the highest possible engine load. If you notice, if now my adjustment was 7 bar to the Pmax, maybe the engine now it's operating in low load. But if I increase the engine load where the Pmax optimally it will be around 170 bar, with my adjustment plus 7 bar, I will lead to the engine running with 180, 182 bars, which can lead the maximum local pressure to the unit. So whenever you make the adjustment of the engine performance, try to make it the highest possible engine load. This is the MN requirement. Okay, so if you notice in this area, wait a while, applying an offsetting Pmax at low load below breakpoint, so below 0.8 scavenge pressure, may lead to high Pmax at the engine increase load. So please take care to perform the combustion test parameter at the highest engine load and the adjustment based on this. Otherwise, you can lead to overpressure to the unit. Gentlemen, on the cylinder pressure menu, we have another facility which will allow us to adjust opening timing of the exhaust valve. Opening timing of the exhaust valve, as I said in first day, is calculated based on the estimated engine load to optimize engine running. So for 58% engine load, opening of the exhaust valve must take place at 125.4 degrees after TDC. This area, it will give me the facility to advance opening of the exhaust valve for individual unit or for all of them with 2 degrees earlier. Gentlemen, this facility, it's available or it will be applicable when the engine is fitted with additional equipment which will increase the efficiency of the engine by using the exhaust gas to power gas generator or to superheat the steam. If I don't have this machinery installed on the engine and I advance opening of the exhaust valve, or all the gases, it will power the turbocharge, and the turbocharge it will goes in overspeed. There were several cases when the cadet or other unexperienced crew member, they come in here and they say, okay, I want to advance 2 degrees earlier opening of the exhaust valve. In this moment, all this energy will be released to turbocharge, okay? And it will overspeed your turbocharge. So never adjust the exhaust valve opening timing if you are not using these exhaust gases in other machinery. Is it clear? This is the procedure to balance the combustion parameter using PMI offline. We have another procedure which will help the crew member to adjust the combustion parameter using PMI online. What is assuming PMI online? During the engine running, the combustion parameter are continuously monitored by the PMI system, which is consisting fixed sensor located on the indicator valve, and the combustion parameter it will be continuously uploaded in the PMI system and in the engine control system on process adjustment menu. You will see I receive order Pmax, order P compression. They are value from here, same value which are coming from here. And you'll notice current P max, current peak compression. In my case, is not coming because the engine is not here. I don't have sensor to monitor the engine. So you receive current mean value, peak compression, current peak compression, current mean value, P max. The deviation between the current and order, deviation between the current and order, and deviation between each unit compared with the mean value. And the offset value, which was already applied by the crew member or automatically applied at the previous adjustment or upload in the previous automatic adjustment. Now, okay, what I tell you. In the engine control system on the MOP, you will see the peak compression, area, order current, and deviation between the individual units compared with the mean value. If this deviation it will exceed the allowable limit, the breakdown it will be in yellow. How you correct in this case? Just press this button and confirm peak compression. This is a button. You will not make any calculation because now the engine control system it will receive continuously combustion parameter, and the adjustment of the timing it will be realized automatically. So press this button and press peak compression. If you want to balance the current or the order, the optimal, you press this button and confirm. If you want to balance the Pmax, the same procedure, this button, or this button, and confirmation, or indicated pressure here and here. So how you make the balancing? Let's assume that you need to balance peak compression of unit number 3. You see this, it will be in yellow background. Press this button and confirm by pressing peak compression. If you want to balance Pmax, you press this button and confirm by pressing Pmax. Same for indicated pressure. If you want to balance all type of the combustion parameter in the same time, you can press whatever you want from this button and press all. In this moment, you balance all the combustion parameter, or engine control system to balance all the combustion parameter. Further than this, we have another button. I named this button magic button. The balancing, it will be realized continuously by the engine control system as long these 3 requirements it will be fulfilled. So index stable, so we have good engine state, good C state, sufficient index, engine load above 25%, around above 50% fuel index, sensor value, so the PMI system in good condition. You press this button, continuous running, and activate start. In this moment, as long these 3 conditions are fulfilled, adjustment of the combustion parameter, it will be continuously realized by the engine control system in order to match the optimal values. So adjust all we discussed, continuous Pmax, or in our case, the button is continuous running. There are different software installed on my engine compared with the slide, but the procedure is the same. So as long these 3 conditions are fulfilling, you just press this button, continuous adjustment, and adjustment of all combustion parameter, it will be done continuously as long the condition they will be fulfilled. Is it clear, gentlemen?
Yes, it's clear.
Good.
Yes.
Not very enthusiastic, huh? Prashad, you are not very enthusiastic, huh?
No, it's okay.
Okay, it's okay. Okay, if you have PMI online, forgot, just activate the button and everything, it will be fine. Okay,
Yeah.
but I need to explain all this facility from MOP to know what that means. Okay, gentlemen, let's take 15 minutes break and we continue with alarm. We continue with other menu from navigational bar. 15 minutes break.
Okay.
Okay, gentlemen, so let's continue. Are you here?
Yes.
Okay. So we continue with the engine operation. Another menu, alarm. Alarm menu, there are 4 submenus: alarm list, events log, manual cutout, channel list. On the alarm list, you can identify all active alarm or all alarm which are inactive but not acknowledged by the crew member. I will simulate one alarm and let's see. So now we can see that on alarm list we have 2 alarm. Description of the alarm: fuse F13 failure. The state of the alarm: they are in alarm state. The alarm identification: ECUB fuse F13, and the time when the alarm was activated. We can notice another alarm, group Tahoe set B failure, and was activated 8:54, 16 seconds. Gentlemen, we can see 2 alarms on the alarm list. In the right top corner, we notice 3 circles and a square. This circle, in this circle, we notice 9 alarm not acknowledged. On a yellow background, again 9 alarm active. So in this area, we cannot see how many alarms are not acknowledged by the crew member and how many are active. We can see just 2, but why the identification in this area is showing 9? The alarm group Tahoe set B failure, so this alarm was activating multiple controller. If I select the alarm and I press expand button, I notice this alarm, failure of encoder B of Tahoe B, was activating all controllers which are receiving the position of the crankshaft from encoder. So all CCUs and both engine control unit ECUs. If you count now the alarm, you will notice that there are 9 alarms which are not acknowledged, 9 alarm active. How I can acknowledge the alarms? I select the alarm and I press acknowledge. Now, if you notice, I have 8 alarm not acknowledged, 9 alarm active. The alarm which was acknowledged by the crew member is changing the background from red to yellow. Or I can acknowledge all of them. I select one of them and I press acknowledge all. Now you notice that all the alarm, 9 alarm active, 0 not acknowledged. So the crew member was acknowledged all the alarm. By selecting an alarm and pressing info button, several details it will be displayed on the MOP related to the respective alarm. So description of the alarm: fuse F13 is blown. The role of the fuse 13 is to protect power supply connector G40 to G61. So the socket G40 to G61. What caused the failure? Electrical overload or short circuit. Effect: signal received on channel G40 G61 may be fault. You notice that a consequential alarm, Tahoe set B failure, was activated. Why? Because the signal from 43 to 47, which are powered encoder B, ECU B, it's power supply for encoder B, due to the fuse failure, the encoder B is not further powered. Action required to be done by the crew member to restore the normal engine condition: check for the short circuit in the external cable G7071 and replace the fuse. Another alarm, so I select this alarm and I press info. You notice all these alarms have the facility for the crew member to see details about them. Description of the alarm, abnormal, Tahoe set B signal on multiple CCUs and ECUs. What can cause this one? Cable failure, encoder failure, Tahoe amplifier, sensor support, power failure. Affect the engine, it will switch to operate just on the encoder A, and redundancy is reduced. We can operate the engine just with one Tahoe, but not without both of them. So the redundancy reduced. So now action to do by the crew member to restore the function. So if it's in one unit, we need to control the lubrication if we cannot stop the engine to identify to replace the MPC. If it's in all unit, we are checking the Tahoe B failure, we are checking the amplifier, or we are replace the encoder. Okay, I will restore the fuse. You notice now that the alarm was removed from alarm list, but now I have another two alarm present on alarm list. Group Tahoe alignment error, Delta Tahoe B2B. Generally, their backgrounds is in green. Why they are in green? Because they are in normal state. So this alarm was activated in past time. Nobody acknowledged this alarm. So 16 alarm not acknowledged, but the alarm are not active. So meanwhile, the state of the poor condition of the engine was recovered, the engine normal condition was recovered. The reason of alarm was disappear, and all these alarm are in normal state, but nobody acknowledged this alarm. So I can select the alarm, expand, because we notice there are 16, but I can see just 2. Also this one, and expand. Delta Tahoe B2B is the deviation between the encoder A and B. Tahoe alignment error, one of the sensors is deviating more than 0.5 degrees compared with the reference sensor. Delta Tahoe B too big, I select the alarm and I press info. Abnormal angle difference between Tahoe A and B. Cause the angle between A and B marker signal exceed the limit. Effect, if the system switch from Tahoe A to B, maximum pressure deviation must be occur. Whatever, we can further operate the engine until we can stop the vessel, identify which encoder is sleep. We discussed yesterday how, and we adjust the respective encoder. Whatever, in our case, the alarm was activated when I switch on the power supply for this encoder, when I put back the fuse F13. For the initial moment, when the encoder was restored, he take the deviation actual position when was disconnect the power supply. And it was a very short moment when it was in deviation from encoder A. But whatever, after he was put back in service, it will start to give normal reading of the crankshaft. So this alarm was getting back in normal state. So I select whatever I want and I press acknowledge all. Now from 16 not acknowledge, all of them are acknowledged. So alarm not acknowledged, alarm active. Events log, the last 1 million alarm, they will remain saved on the MOP, always last 1 million alarm. I have this arrows which will allow me to search to this alarm by pressing this multiple button. I go to the latest alarm. You notice today 9:01 UTC time. I can search alarm to move the searching line by line, unit by unit, page by page, or I can go to the first alarm from this last 1 million by pressing this multiple button. So it will allow me to search through this alarm. Identification to the controller where the alarm it's activated and unique identification of the alarm, date on the alarm, time, description of the alarm, and actual status. They are in normal, manual cutout, automatic cutout. It will happen when the engine is stopped and the alarm was acknowledged by the crew member. Gentlemen, there are a lot, 1 million alarm, there are a lot. The MN give the facility to search through this alarm based on the unit identification of the alarm or the controller where the alarm is activated or on a time interval. By pressing this button unit, I want to see the alarm from last 1 million alarm. I want to see the alarm related just to the CCU number 3. So I press unit and I will write CCU number 3 and I press apply. So in this moment, I can see all the alarm related just to the CCU number 3. From 1 million, maybe it will be 20,000. I want to evaluate just a particular alarm related to the CCU number 3. So I want to evaluate delta or Tahoe set B failure. I want this alarm. The identification is 0, 10, 10, 4 to 8. So I press this one. Tag 0, 10, 10, 4 to 8 to the CCU number 3 and I press apply. So now from CCU 3, all type of the alarm, I can see the alarm related, unique alarm, Tahoe set B failure. So I noticed that this alarm was activated on 24th of November, 8:54. 8:66, someone acknowledged the alarm. The background was changed in yellow and the alarm was acknowledged. And 5 minutes after alarm was activated, the crew member restored the normal condition of the encoder. You notice it's getting in normal state. So based on this, I can see the evolution of the mechanical equipment evaluated by this alarm. I'm pressing unit tag filter, I can see all the last 1 million alarm. I can search based time interval when the alarm was activated. You notice now by pressing this button, time span, I have the possibility to insert the dates which I want to evaluate the alarm. So today we are in 24. I want from 15 November, wait a while, year first, 2021. November, it's 11, 15 until 20 of November, yeah, 2021, 11, 20, and I press apply. Now, gentlemen, I evaluate just this 5 days alarm. I go to first of them from this 5 day which I want from 15 2020. So I notice the alarm just in this particular 5 days, yeah. Still in 15. Okay, I go on multiple page. 19, probably 20 it's in weekend, maybe it's not, or we don't operate in 20. We don't have in 20, the latest was in 19. So in this way, I can search on interval time. I have another button here, go to daytime. By pressing this button, I can evaluate the alarm from a past day hour until today. So I noticed that the problem with the engine starts from yesterday. So I insert 23 November from 5 o'clock in afternoon, 1700, and I press go to date. In this moment, I evaluate the alarm from yesterday, 5 o'clock until today. Gentlemen, info button, by selecting the alarm info button, have the same facility like in alarm list to see several details about the alarm. The info button is available on all 4 submenus in alarm menu. Export. I have the possibility to export the events log on external hard drive or USB by pressing export button, inserting an USB in the slot of the MOP and press save. This last 1 million alarm, they will be saving spreadsheet format on external hard drive and you can pass to the company using a mail. Nobody want to evaluate 1 million alarms. So before to export, I suggest to evaluate just a certain time when you have the problem to be evaluated. How you export a certain time? By pressing time span filter, select the dates, select the period when you notice the problem with the engine, apply this selection, and after that export. In this moment, you will export just this data selection. If you make a selection on unit tag, at the export, it will not filter events log based on unit tag. It will be filtered always exporting just by time interval if you want to make this kind of solution. As I said, nobody want to evaluate 1 million alarm. So special when you have some problem, export just a specified period when you have this engine problem. Manual cutout. In the manual cutout, you notice another circle here. There are 4 manual cutout alarm. Gentlemen, the crew member is aware about the engine failure. This alarm related to this failure is activate, inactivate based the engine condition, and the crew member are aware and they didn't want to be disturbed during the regular working time or during the rest period. On my engine, I am aware that I don't have online the system, the software is PMI online, but the engine is not here, so I don't have the sensor installed. And I have an alarm related to the cylinder pressure deviation and sensor in the PMI system not valid. These alarms are getting active during the engine high load, inactive during the engine in low load operation. And I am disturbing teaching process. You notice now they are in alarm in status. And I prefer to keep them cut out. I want to reactivate. I select the alarm and I reactivate. Instead of 4, it will remain 3. And I have 1 alarm not acknowledged and active. I want to reactivate all of them. I select and I reactivate all of them, okay? You notice the value of the active alarm, it will be reduced. Now it's just 1, and I think I reactivate also this one. So now if I go in the alarm list, I can notice all these 4 alarms which are active. I press acknowledge, I acknowledge all of them. As I said, I reduce the engine load, they will go in normal state. I increase, they will get activated, and I will be disturbed my teaching process. Same, if you have low battery, worn out battery, CCU number 3 or engine interface. In nighttime, the alarm is active to the cold temperature. Daytime, the alarm it will get in normal state. So you don't want every night, 11 o'clock, to go to reset this alarm. You know that the battery quality to not affect normal operation of the MPC. You select the alarm and cut out. How you cut out? You select the alarm and press cut out. Now you notice instead of 3, there will be, instead of 4, there will be 3 and 1 cut out alarm. Okay. In channel list, you can identify all possible alarm which can be activated on this engine do abnormal operation. On my simulator, I can have 1,131 different possible alarm. I am using this list as a reference list. I have the arrows which will allow me to search through this alarm. So I can select one alarm when I have in free time and I want to increase my knowledge about the engine. So I select the alarm, illegal fuel plunger movement, slow down. And I press info. Description, fuel plunger has made an illegal movement. Description, risk of on-time fuel injection. Cause, plunger position sensor or cable failure, FIVA valve failure, CCU failure. Effect, no fuel injection to the risk of on-time fuel injection. For FIVA installation, no exhaust valve operation, slowdown is requested. Action, fuel plunger position, fuel plunger sensor and cable. You'll notice several actions which is recommended to make by engine control system by maker in order to restore normal conditions. So you have some free time, you take one by one this alarm, you evaluate what can be the causes, how you react in case this alarm it will activate during the engine operation. So it uses a reference list. Fuel plunger stroke too low. Let's take this one, info. Fuel plunger stroke are shorter than ordered by the engine control system, cause injection valve failure. Fuel oil viscosity too high. Hydraulic oil pressure too low, FIVA valve failure, fuel plunger stuck, effect, injection fuel amount incorrect, exhaust gas temperature reduced, reduced cylinder performance, action, check fuel injection valves. Okay, but we can notice also FIVA can be failure, also fuel booster. So they are giving some short descriptions, short causes and action required for the crew member to be done to restore the normal engine running condition. Okay, so I think I complete also the alarm menu. Engine menu is complete. We'll discuss later on auxiliary. We go now to maintenance menu. General maintenance menu, it will help the crew member to identify abnormal engine operation or to perform some testing engine control system and also in the mechanical equipment. First maintenance menu is system view. Some menu is system view. On the system view, you can notify all the controller which are belong to the engine control system and their state. We notice we have engine control unit that operate normal, active. Always the engine control unit A it's in control mode, ECU B it's in standby. So what are duplicated controller? A it's in controlling mode, B in standby. I cannot change by myself which to be in control, which in standby. By default, A controller is in control. If it happen a failure with A controller, automatically B it will take over the engine control, engine speed, it will not be altered. I noticed that all of them are active. ECU, they are connected with LOP. The role is to process the running parameter. Engine interface 2, the role to communicate with the external system. Auxiliary control unit are control auxiliary engine equipment. CCUs are controlling the monitoring the combustion, the engine itself. Two networks are connect all these controller. Other state of the MPC, this MOP. So now we are evaluating the engine from MOPB. Test, as we discussed yesterday, if we want to perform some test, we are accessing the controller and we change from normal in test mode. Now the engine is running. I cannot, of course, I can change in test mode that, but the respective equipment which are control monitored by the controller which was switch in test mode, they will not be controlled normal. Yeah. So do not change in test mode with the engine under running. Configuration. See if in this area it will be C. This is means now I can make a configuration of ID key, a programming of the ID key, or a local configuration of different electronic components. B, blocked. B, this is means that the controller is connected to the engine control system, but the application is still not operation. The application is initializing or is downloading. Blocked. Not accessible, these diagonal red strips. Not accessible, this is means that the controller is not found in the network. Maybe it's disconnected or the power supply is off. Gentlemen, I can access all these controller one by one. So I take engine control unit A and I can notice the hardware which is using. The hardware is MPC. If I close this one and I take a CCU, I can notice the hardware is MPC10. So in my engine control system, I am using two type of the hardware. MPC for all the controller, less than CCU, in which I use the cheaper version MPC10. Sorry a moment, gentlemen. Wait a while. We can access all this MPC and we can see the signal which is managed by each of controllers. So we can see the signal, control signal to different actuator, or a signal from different sensors which are monitored some actuator mechanical equipment. So the signal could be analog or digital input. So input, the arrow is from the number number of the socket or the description, or output signal, the arrow is from the description of the socket toward the channel number. Now, I notice cylinder lube oil, digital input, analog input, FIVA, position feedback. So feedback sensor which is monitor the position of the FIVA, 31 fuel plunger position, analog input signal. I can select one by one this channel and I can see channel 31, description fuel plunger position is monitor fuel plunger. It's an analog input for 20 milliamps, the electrical value and process value. So I can identify what kind of the signal is managed by any of these controller. This is CCU number 2. I can take one by one this controller. Now the signal, as I said, I am using in ECUA, the MPC, 55 of socket. The MPC design, it's with 55 of socket. From this 55 of socket, maybe I am using 30 or 40, and 15 of them or 10 of them are not used. You notice, not in use, not used. The socket can be configured as not available. Gentlemen, on my engine, I configure multiple socket as not available. You notice I configure start air pilot valve not available, lubricator digital signal to lubricator valve not available. Why? I don't have engine here. If I configure this as on-off signal, I will activate an alarm. Okay, so I have multiple alarm activate on my simulator. So I prefer, in order to avoid this multiple alarm during teaching to be activated, as the engine is not here, to configure it as not available this signal. Okay, so the signal, the socket is configured with what kind of signal must be managed, but I make them not available. Alarm we discussed yesterday or before yesterday. In case one of the input output signal is one of the cable is connecting wrong socket, the respective socket, it will be in respective signal, it will be in alarm state. You notice channel 35, it is analog input from turbocharge sensor, pickup sensor, which is monitor the turbocharge speed. But what I've done, I disconnect the cable G35 from the MPC socket and I connect on G40. And you notice, do the mistake of the connection, the respective socket, it's in alarm state. So the cable is not connected in appropriate mode. I search again and I connect back. Okay. Gentlemen, if you notice on ECUA MPC, I am using from 55 of socket, maybe I'm using 40. Channel 40, it's let's see, I'm not using 40, maybe 50 or whatever I'm using if I count here. Channel 41 is configured by engine control system with the software downloading as digital input from marker slave A. This is the role of this socket. Now let's assume that I have a failure of the socket. I was careless at the replacement and I remove the socket from daughter board. It's not daughter board, main board. So I remove the socket. Physically, I destroy the socket. Now, in order to restore the controller, I need to replace with a new one. But I have another opportunity. So I destroy this socket, channel 41. Let's see if in other let's see if on another controller mode, the MPC channel 41 is not in use. I will access system view and I check scavenge control unit. From 55 of possible available socket, I am using just 6, you notice? And G40 socket is not in use, yeah? Is nothing use. So I can sweep this controller and I can repair or I can resume further engine full operation. Even the socket G40 on one MPC is destroyed. Is it clear? Kenan, Nikolai, Yuri, Prashad, are you with me?
Yes, clear.
Okay.
Yes,
Clear.
Okay, Jen, sometimes I just ask if you understand what I am explaining here. So I can sweep these NPCs. This one, which earlier was used as scavenge control unit, I will take from the panel. I am in the panel of engine control unit. It will become engine control unit. G40, which is not in use here, it will be in use. And from engine control unit, the NPC which have socket G40 or 41 destroyed, I will install a scavenge control unit, and on that position it will work very well. So I make some saving from company, yeah? Okay, let's see what we can discuss further here. System view, we revert back to another condition of the input output signal. We discuss not available, alarm, not in use. We revert back to invalidate condition later on. Network status. Gentlemen, on network status, we can see the quality of the connection of each MPC using both network with other controller. We notice on the horizontal line the type of the controller belong to the engine control system, the number of identical controller or with the same role controller, engine control unit, how many we have, A and B, engine interface A and B. Each MPC, as I said, is connected to arcade network with the other controller. So engine control unit B, network A and network B. Network A is connected with MOPA. Network A is connected with MOPB. Network A is connected with engine interface. So I can evaluate the quality of each network connection of one of the controller with all the other controllers. So I can evaluate status of connection. Okay. Now, please help me to identify what kind of the failure it's available now in the engine control system. Huh? Please allow me if you can identify any failure in the engine control system. Can one,
Network B scavenge control unit.
right, gentlemen. So we notice scavenge control unit. How many we have? One, network A, network B. So network B is disconnecting from all of the controller. We don't have communication on network B. If we go on system view, we can notice that the scavenge control unit, it's in active mode. It's operating normal, but the communication is realized just using one of the networks. Is it clear?
Yes,
Yes,
clear.
clear.
Very well, very well.
Connection problem.
Okay, a connection problem with one of the network. But now what can be, what you think that is the problem?
Both A and B network.
Yes, both network are disconnected, or power supply now is required to upload also here, or power supply is disconnected from here. So maybe it's the MPC is disconnect from the network, both network, or the MPC power sources is remove. Is required you have a bug, but it's not a bug, but you have some delaying in uploading this this failure here. Wait a while, I need to show you also this one uploaded. So let's wait a while. I think soon it will be. Now, okay, now you notice also it's showing in a system view, input output is showing a failure of our MPC not connected. Allow me to connect back in the on the network this MPC. Wait a while. Sorry, a moment. I'll try to make something else. Wait a while. Okay, can you tell me now what can be this possible cause for this kind of situation?
Network A is out of order.
Yes,
Totally.
Yuri, you notice that at the lowest position of this table, which is showing the individual connection of each MPC, we have a network A quality connection and network B quality connection. Now you notice that the network A doesn't communicate with any of controller belongs to the engine control system. We have a complete collapsing of one of the network. What can be the cause? The cause can be a wire broken, so a wire was cut, or as I tell you in the first day of the course, at the each end of the network, we have 120 ohm resistor with the purpose to close and stabilize the network. If one of these resistor of the network A end, so ECU B or MOPB, it's worn out, it's burnt out, the network, complete network, it will collapse. So mainly this is the reason of complete network broken, the resistor in end of the network. Clear? Okay, I restore back this. So what I done, just I disconnect the resistor from MOP, from MOPB. Is it clear? Now,
Yes.
good. Okay, gentlemen, as I told you in previous days, let's see what time is it. Okay, we can go. As I told you in the previous days, the system, several systems are duplicated by pressing details button on the engine control system. We can notice that air pressure system, control air pressure system is monitored by two sensors. The input of this sensor is reaching different controller, different auxiliary controller in ECUs or engine interfaces. On auxiliary, by pressing details button, I notice that inlet lube oil pressure is monitored by three sensors. By pressing detail, I can notice individual value of each sensor. Unpress detail button, engine control system, it will operate or it's operating on mean value. But the engine control system, it will perform meaning value of this sensor as long the deviation of this sensor, it will be within a certain level, in a certain limit. If the deviation it will exceed this certain limit, automatically the engine control system it will react in different way. So now let's assume that I will simulate the inlet pressure of lubricating oil inlet pressure to the pump number 1 instead of 2.3, how much it's a real one, I will simulate 1.8. So let's see how we'll deal with this new situation, the engine control system. Allow me to simulate 1.8 bar, pump number 1. Okay, you notice inlet pressure, it's 1.8, pump number 1, 2.3, 2.3. What is doing the system? The system is making the average of these three sensors. So this is the inlet lube oil pressure taken into account by the engine control system. But if one of the sensors it's deviating from the closer two values more than 1 bar, the engine control system it will disregard the respective sensor. So now I will simulate 0.8. So let's see what will happen. You notice I have the sensor 0.8, 2.3, 2.3. The engine control system pressure, inlet lube oil pressure is 2.3. Why? Because this sensor was disregarded. And we have an alarm which will inform us that the inlet pressure sensor auxiliary control units deviate from the closer to. Is it clear? So the engine control system is aware to remove the failed sensor from the system in order to have an appropriate reading of the inlet lube oil pressure. Gentlemen, the system, as I said, there are multiple systems and the meaning level, level of averaging is different based on the range of measurement. So for inlet lube oil pressure, the sensor it will be averaged as long the deviation it will not exceed 1 bar. For outlet pressure, the sensor it will be averaged as long the deviation it will not exceed 10 bar. So they are measuring around from 0 to 300 bar. Of course, we have increased a range of measurements, so deviation limit it will be increased. Now, I assume that you understand what I want to explain. But if I go now, wait a while, if I'll go to the scavenger, this is actual scavenge pressure. By pressing detail button, you will notice that the scavenge pressure, is monitored by two sensors. The system it will perform the average value as long the sensor value, the deviation between the sensor value, it will not exceed 0.2 bar. Now I will simulate the sensor number 1 instead of 3.23 bar, 315. Let's see what will happen. Scavenger pressure 315. 315. Enter. You notice this sensor value is 315. The other one, this is the wrong sensor. This was simulated by me. The other one is 312, 314, 317. By I'm pressing detail button, I notice that the system is performing the average value of this tone. But as I said, the averaging is available as long the deviation is not exceeding 0.2. I will simulate the sensor number 1, 1.15 or 0.15. I will simulate 1.15. How will deal the engine control system in this moment? Because we don't have three sensors to, in order to cross-check between all these three sensors to be easy to identify which is wrong. Now I have just two sensors. One is 1.15, the other 3.23. How the system it will understand which is good or bad? Any answer? So gentlemen, I will simulate and let's see what will happen. So this is wrong sensor, which I simulate. So let's assume this is the reading of this sensor, 115. So this is the wrong sensor. This is wrong value sensor. So what you expect to be the scavenge pressure in the system now? I will unpress detail button, and you notice that from two sensors, the system is taking the pressure 115. So I have two sensors. One is 115, the other 271. This one is the wrong sensor. but the system was so stupid that it's choosing to operate the engine further on the fail sensor. Why is doing like that? Nikolai, do you have experience with the engine? Yes?
Yes, but I can't, now I can't find the solution.
So, gentlemen, the system doesn't know which is good or bad and is choosing to operate further the engine on that one which is giving safe running. What will happen? If pressure, actual pressure, it's 115, so good sensor, it's 115, the engine, it will limit it, wait a while, the engine, it will limit the fuel index based on lower scavenge pressure. Actual pressure, it's 115. But if actual pressure, it's 115, and the engine is choosing to operate the engine on 270, I will not have scavenge limitation, scavenge pressure limitation, and I overfuel the engine. If actual pressure is 270, 269, and the wrong sensor is showing 115, I limited the scavenge pressure, but I will not have any problem with the engine. Just the scavenge pressure, it will limit it. I will not overfuel the liner. But if I choose 270 and real was 115, I will over fuel the liner. You understand me? So the system, it will choose that one which is give secure running to the engine. Doesn't matter which is good or bad, because the system
More safety.
more safely. Yes, it choose that one which is gives safe running for the engine, right? Now, gentlemen, I am a crew member. You notice that I have also some alarm, deviation supervision, ECUA. So this is the input of this sensor, ECUA, ECUB from scavenge pressure. Now you notice that the system is telling us that I have a deviation between this sensor. I go local. What I am doing? I am go local and I check local manometer, and I see that the local manometer is 269, 270 is the pressure. So I understand that this sensor must be replaced. Gentlemen, if I don't have sensor to replace, because I cannot have all type of sensor on board, if I don't have the sensor to replace, I can tell to the engine control system that this sensor, it's out of order. How I tell to the engine control system? I need to find where this sensor is sending his information. Based on the alarm, I can identify deviation supervision, channel 35, ECUA or ECUB. So let's take one by one. Maintenance, system view, ECUB, channel 35, scavenge air pressure is 269, local is 270. So this is good sensor. I'll go system view, ECUA, channel 35, scavenge pressure, it's 115. So generally in this moment, I understand that this sensor, which is sending information to ECUA, it's a wrong sensor. I select this channel, process value, invalid. So in this moment, I tell to the engine control system, do not take anymore in account the reading of this sensor. And you notice a number, a value here in this square. One sensor invalidate, one. Invalid inputs. On maintenance menu, invalid inputs, scavenge air pressure. If I go now on auxiliary, scavenge air, you notice that this sensor was disregarded. Actual pressure is 3.23. So the engine was removed the limitation on scavenge air, reduce scavenge air. So now I can increase further the engine speed to the maximum because I identified that the problem was given by fail sensor. Is it clear? Gentlemen, you can invalidate all type of the sensor. Okay? Less than encoder sensor and FIFA monitoring LVDD sensor. Otherwise, you can invalidate. But be careful, before invalidate a sensor, cross-check with the local condition. If the local condition are out of order and you validate the sensor, you lead to the failure of the engine. You invalidate a sensor which is monitor the stroke of the exhaust valve. You can operate further the exhaust valve with the pressure, scavenge pressure more than 0.8. But if the scavenge, if the exhaust valve is remain stuck in closed condition, you leave the cylinder cover. You understand me? So always before to invalidate a sensor, check that the actual mechanical equipment supervised by this sensor are operating properly, and after that we can invalidate. Okay.
Sure. But anyway, I can check even a local pressure gauge, for example, by a master pressure gauge.
Yes, we can connect a pressure, local
That's
pressure.
more easier. So
Right.
if I rely, I will do for system the correct.
Yes, you can connect there a manometer. You have a digital manometer. You can check in any point. You have some checking point also in the hydraulic system. And you can check with this digital manometer. On the checking point, you are cross-checking with the reading from the sensor. And if you identify a wrong reading, you disregard, you invalidate the sensor, or or better to replace the sensor, but is the risk to not have the sensor, all type of the sensor. Now, gentlemen, you notice I have an alarm. No cylinder lube oil supply, slow down. So I don't have cylinder oil to the unit number 1. What I am doing, you notice I have also slowed down because the liner is not lubricated, telegraph position, slow down from alarm monitor system or from other systems, slow down. In our case, it's from engine control system. So I access maintenance menu, system view. So CC1 is that one which doesn't have lubrication, CC1, unit number 1, maintenance, CCU number 1, channel 21, cylinder lube oil level, the sensor is failed. I select this one, process value, invalid. And now I can reset the engine and I can reset the slowdown and to increase the engine speed to full ahead. It's okay what I done?
Not fully, sir, because
Yes.
we can monitor more.
Yes, so I go local, I disconnect 1-2 pi from the lubricator to the injection lube oil valve. I cross-check local that the cylinder oil is going from alpha lubricator to the injection valve. I'm confident that I have cylinder oil. Now I understood that the problem is with the feedback sensor, which is giving the flow in the tank, which is giving the presence of the cylinder oil on the lubricator. And of course, I don't want, maybe I'm in the bad weather, I don't want to stop the engine to replace the sensor, but I am confident that I have lubrication. I can invalidate the sensor and to run further the engine. Is it clear? So
Yes,
always cross-check local. MM, they said never invalidate a sensor without their approval, but in the classroom, they are just chief engineer and first engineer, second engineer. So I'm confident that we have experience with the engine. Now, gentlemen, in maintenance menu, invalid inputs, we notice that we have 2 sensors invalidate. Whenever you join a vessel, please check the sensor which are invalidate, discuss with the engineer, chief engineer, the previous one, what was the cause of invalidation of the sensor. Otherwise, you would not have the protection on the engine. So the difference between the cutout alarm and sensor invalidation. Cutout alarm information from engine control system is not available to the crew member. Invalidate sensor information from the sensor is not available to the engine control system and to the crew member, of course. So take care. Cutout alarm, of course, you are aware about the information always is reaching the engine control system in case something abnormal is happened, the protection is available. But by invalidating the sensor, you will not have any protection in case of failure in the mechanical equipment. Now, you can valid, so let's assume that you reach to the port, you receive the appropriate sensor. After replacement the sensor, you select the sensor which you want to validate either by direct on invalid input, or you can find in system view engine control unit A. You notice this invalidate, this yellow diagonal stripes, which is indicate that the sensor is invalid. You select the sensor after replacement and select as valid. Okay, or direct on maintenance menu, invalid inputs, you select cylinder lube oil and set valid. Okay, gentlemen. Okay, let's take 50 minutes break and we continue. Okay,
Okay.
you further with other menu from here. Okay. Okay, gentlemen, let's continue. Yes. Are you here?
Yes, here.
Okay. Yeah, sometimes just asking maybe the connection is poor or was lost. So just like check if everything is okay. So we continue with maintenance menu. We'll discuss system view, invalid, net or stat. We go to function test. Then the function test is the procedure which is required to be performed by the crew member in order to test the new equipment installed on the engine. We test encoder after the replacement. We perform procedure function test for the encoder after was replaced by us yesterday or adjusted. So it's the procedure to test the operation of the new equipment and to calibrate their operation with engine control system. We can perform the procedure function test at the replacement of the components of the hydraulic cylinder unit like FIFA valve, fuel plant, exhaust valve, their feedback sensor, or we can perform procedure function test in case we are replacing a mechanical driven pump and they are associated equipment like proportional valve, feedback sensor. Whatever we'll do this tomorrow, hydraulic cylinder unit, today later on hydraulic power supply, after we discuss a little bit about hydraulic system. Speed handles, we have a procedure to calibrate the telegraph located in the engine control room or on local operating panel. We notice that we can calibrate local operating panel telegraph or engine control room telegraph. We have two buttons, set RPM only or set number of position. Generally, according to the position of the telegraph, stop, start, slow ahead, and so on. By moving the telegraph, we notice that in engine interface A, engine interface B, they are receiving from the sensor located in telegraph electrical current, milliamps. Based on this milliamps received, the speed set is adjusted by the crew member. So at full speed, when the telegraph is full speed, is required that the engine to operate at 75 revolution. On my engine, this is the by default designed by me, but I want at full speed my engine to operate with 80 revolution. What I am doing, I set this button, set RPM only. By pressing the next button, I will move the adjustable line to the area which I want to perform some changing. So I go next, 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 next. Full ahead. I want from now on, when I switch the telegraph to full ahead, the engine to turn with 80 revolution. Using now the arrows, I set a new RPM, 80 revolution. I'll press next button and I will press apply. Now, when I control the engine from engine control room and I set the telegraph to full ahead, the engine will operate with 80 revolution. Is it clear? Okay. Whatever, make a picture before the adjustment. I know that always I make the same adjustment, so I set back to 75. Next and apply. So this is the facility set RPM only to adjust the speed of the engine based on the telegraph position. I have another facility, set number of position. If I replace the telegraph with new type, instead of 6 position ahead, 6 astern, maybe I have 7 position ahead, 7 astern. I press set number of position. I adjust the new number of position. I press apply. In this moment, all this data from here, it will be erased. I keep the telegraph in 0, in stop. You will notice that I will receive some currents. I will set 0. I move the telegraph 1 step ahead. I will receive the new current and I set the speed for that slow ahead. I move the telegraph one step ahead. I will receive other currents. For the other currents received with new telegraph, I set a new speed. In such way, the replacement of the telegraph, I adjust the new telegraph according to my desire. Whatever, if you replace the telegraph will be replaced by MN or in regular, you replace with the same type of the telegraph. You will not use a new telegraph. Whatever. Mainly, I was not use as chief engineer this facility. Just on as superintendent engineer, I used other replacement of telegraph. You will not change by yourself the telegraph. So mainly, you will not use this facility. But just to explain what is the role. As I said, hydraulic power supply function test and hydraulic cylinder units will discuss in next days, hours. We'll go to the troubleshooting. The troubleshooting procedure is the quick, clear way to identify the failure in the engine equipment or the failure in the engine control system. So I can identify failure in the combustion units, all the units 1 to 6. I can identify the failure. I can perform the test to identify the failure in mechanical driven pump. I can evaluate some electrical signal which are describing operation of the mechanical equipment. But we go now to the isolation menu. We access direct the isolation menu because for the other one, we'll discuss a little bit their components mechanical part. Now, gentlemen, we notice on the isolation menu troubleshooting or maintenance troubleshooting isolation, the controller which belongs to the engine control system in one column. In the second column, the isolation between the MPC, the hardware, and panel and the ship hull. If the isolation is above 500 kilo ohm, the isolation it will be set to 500. If the isolation it will start to be reduced, so we have a continuity between the panel and ship hull, you will notice the isolation level it will be start to reduce below 500 kilo ohm. Actual isolation it will be displayed. If the isolation it will go lower than 80 kilo ohm, an alarm it will activate, which it will help the crew member to realize that we have a poor condition of the engine control system of the respective controller in the engine control system with the ship hull. So I'll try to simulate a low isolation for one of the controller. What I am doing, I'm just connect a wire between the MPC and the panel. So I create a continuity between electronic equipments and ship hull. Wait a while to create this cable connection and we'll discuss based on it. Now you notice everything is normal. I start to deteriorate the resistance. You notice the auxiliary control unit number 2, the isolation start to reduce also for number 1. And when the isolation goes below 80 kilo ohm, an alarm it will activate in engine control system. I hope that you can easily notice this on the MOP. Okay, let's try to identify now what has happened with this alarm. Let's try to evaluate this alarm. You notice now it's 45, 45. I go on alarm, engine control system isolation below normal level on auxiliary control unit. I select the alarm and I press info. Engine control system electrical isolation below normal service cause one of more engine control system components have increased electrical leakage to the vessel, to the ship hull. Action require check isolation level by observing the display to the OK. So generally, how identify the electronic equipment which is leading to low isolation? How identify low isolation in main switchboard? Let's assume that you have low isolation activate in main switchboard of your vessel. How you identify this low isolation? You stop the vessel, stop the engine, and you will disconnect one by one the electrical equipment's power from main switchboard like fan, pumps, or other electronic equipments. Until you notice that the isolation to revert to normal level, the last equipment which was disconnected is that one which is giving low isolation alarm. Same will proceed on MOP. With the engine in stop condition, I access auxiliary, I access maintenance, system view, the low isolation alarm the low isolation alarm is present in auxiliary control unit 1 and 2. I select number 1 and I notice the electrical components which are connected with the MPC auxiliary control unit number 1. I start to disconnect one by one this socket, okay? Channel 21, I evaluate the resist, the isolation, same level, channel 22, channel 24, and so on. When I remove channel 36 analog, so is the sensor from control air pressure, I notice that the isolation goes back over 500 kilometers. So I identify that the equipment which is giving low isolation is the sensor which is monitor the control air pressure. Could be the sensor, could be the connection between the sensor, MPC, chaffing cable, or other problem in the electrical equipment. So in this moment, I identify, I evaluate this connection, and I restore normal service value for low isolation. Is it clear? Okay. On troubleshooting, gentlemen, we have another column further than isolation, noise pulse counter. What is the noise pulse counter? Noise pulse counter mainly is developed during the engine running due to the vibration on the engine. Mr. Kenan, switch off your microphone. If you don't want to ask something, please keep it switch off. So let's assume that we have a chaffing cable or a poor connection of one of the equipment. This is to lead to the vibration to the short period of connection between the ship hull and electrical signal. So it's a intermittent or oscillating low isolation. So we don't have a continuous low isolation. It's a intermittent low isolation, mainly led by the poor condition of the electronic or poor condition of the connection of the equipment in the engine control system, or the low isolation, intermittent low isolation, noise, electrical noise can be generated by the large electrical equipment located near the engine control system, can be affected also by other equipment. So I will start to generate some electrical noise on the engine, and based on this electrical noise, so what I am doing, this cable which was earlier connect continuously with the MPC, just I try to connect and disconnect quickly. I will simulate some vibration, and the cable which is not well connect to the controller or a sensor, chaff cable which is touching the ship hull. Okay. So now, if we are evaluating noise pulse counter for auxiliary control unit number 2, we notice that we have the value it's increasing to 11. So we have 11 short period when the isolation goes below normal service, was a not continue low isolation. What is the difference between the permanent low isolation and intermittent low isolation? The problem is that it's difficult to identify the source, because mainly this is generating, you see now I stopped touching that one. So mainly if I stop the vessel, the noise pulse counter, it will get steady stop. So in this moment is required to check the connection from auxiliary control unit number 2 with all components control managed by this controller. I don't have any other opportunity how to identify this low isolation source. If I go on the alarm now, electrical noise detecting, I select the alarm and press info. Cause one or more engine control components has intermittent or oscillating electrical leakage to the ship ground, so it's not continuously. Engine control system has been subject to electrical noise from external source. Gentlemen, effect on the engine, no immediate effect. So this electrical noise is not affecting immediate engine control system, but you notice you have a deterioration in the engine control system. But be careful to the second statement. The fault can generate other consequential alarm in the engine control system, like exhaust valve close position change, exhaust valve closed position opening too fast, illegal FIVA position, LV feedback FIVA signal. So these electrical noise are generate a false signal in the engine control system. Even the equipment is operating normal, exhaust valve is operating normal, FIVA is operating normal. These electrical noise are generate false signal and they will lead to the slowdown of the engine. As I told you, the respective unit it will be in failure. So as I told you, if electrical noise is available, it will give false signal and the respective unit it will be in failure. Allow the engine to slow down and try to reset. Check the noise counter. If the noise counter is increasing with electrical noise, if it is resetting, can further resume the engine operation. But with first opportunity for the respective unit where you have increased counter in electrical noise is required to check entirely cable connection and integrity of the isolation cable and condition of the mechanical or electrical equipments managed by this unit, by this auxiliary control unit number 2 in our case. Okay, I think so. My advice, when you join the vessel, try to reset the counter to 0. How you reset the counter? By pressing reset button on the NPC or with the engine in stop condition, or switching on the power supply for the respective controller. The counter it will get back to 0 and you will evaluate daily if deterioration in the engine control system will be present in order to take in time corrective actions. Gentlemen, let's continue further with the chapter number 4, hydraulic power supply. But before to continue with operation from MOP, we'll continue with presentation from slide of this chapter. Okay. Let me just go there. The camera is well there. Okay. Let me try to find this. Chapter 4, hydraulic power supply. Hydraulic power supply. The topics which will be discussed by us: system, filter, startup pump, engine driven pump, electrical driven pump, and valve block safety valve. As I said at the first day, we are using lubricating oil to power the mechanical equipment. So lubricating oil will become hydraulic oil. 90% of lubricating oil delivery by main lube oil pump, it will fulfill the same requirements to lubricate and cool mechanical equipment. 10% it will be fine filtered by an automatic backwash filter 6 micron. And after that, lubricating oil it will be pressurized. During engine in standby mode and in low load operation, the lubricating oil it will be pressurized by 2 pumps powered by electrical motor named startup pump. These startup pump are axial displacement piston pump, fixed flow. During normal engine operation, above 15%, the startup pump are stopped. All the hydraulic pressure, it will be generated by 3 to 5 mechanical driven pump powered by the engine crankshaft. There are 2 different hydraulic systems, 200 bar or 300 bar hydraulic system. In 200 bar, you will find from 3 to 5 mechanical driven pump, at least 3, maximum 5, depend the engine size. In 300 bar, you will find always 2 startup pump and just 3 mechanical driven pump. Mechanical driven pump are axial displacement piston pump. They are adjust their flow according to the engine load in order to efficient the engine consumption, engine running condition. Hydraulic oil, it will be delivered to hydraulic cylinder unit, either using double wall pipe in 200 bar system or common pipe in 300 bar system. The oil after was used to activate fuel booster or exhaust valve, it will return back in some tank. So what we discussed: main lube oil pump, main cooler, 50 micron filter. In this area, 10% it will be pressurized hydraulic oil, 90% it will use for same reason to cool and lubricate the mechanical equipment. Okay, so filter, you notice from main lube oil pump, 10% it will be filtered in normal engine operation by an automatic backwash filter 6 micron. If this filter suffer a failure, we can resume the engine operation by bypassing the automatic filter through a manual filter 25 micron. Gentlemen, you notice the quality of filtration according with the International Standard of Organization or National American Standard. In order to improve the quality of oil, MN is recommended with the engine in stop condition twice per month to remove 25 micron filter instead of it to insert a superfine filter 5 micron, to open this manual valve 160 and to recirculate the oil through this superfine filter now twice per month, at least 4 hours. After you recirculate, you insert back 25 micron filter and you resume normal operation on automatic, or you resume the filtration on 6 micron automatic filter by closing this valve. So in normal operation, we are filtered by 6 micron automatic backwash filter, and the oil it will be pressurized, lubricated oil during the engine in low load standby by 2 pump powered by electrical motor. The set point pressure of the startup pump, it's 175 bar in 200 bar system or 225 bar in 300 bar system. The set point pressure is achieved by adjusting relief valve position 312 in hydraulic system. During normal engine operation, the lubricating oil is pressurized by 3 to 5 mechanical driven pump powered by the engine crankshaft. Each pump is provided with a nitrogen accumulator with the purpose to stabilize and compensate the hydraulic pressure, to stabilize the engine pressure and compensate the deviation. We notice on the hydraulic system there are 2 valves with the purpose to protect overpressure, the valve 310 and valve 311. The valve 310 it's open at 230 or 310 bar, depend the system. The valve 311, it's open at 250 or 315 in 300 bar system. The way it will be delivery, this is double wall pipe connection to the hydraulic cylinder units. This is 200 bar system, double wall pipe connection. In 300 bar, it's a common pipe protected by shield gallery. In 200 bar system, the inner pipe is used to circulate the oil, the outer pipe to protect the environment. In case in 200 bar system, we have leakage between the double wall pipe, the leakage it will be lead to the sump tank. An allowed leakage 10 to 10 bar, it will not affect the engine operation. If the leakage between the double wall pipe is reaching 10 to 20 bars, we have a pressure traducer which is showing us the pressure in double wall pipe. It is required to stop the engine to identify the area of leakage and to replace the sealing ring o-ring there. If the pressure inside of double wall pipe is to reach more than 20 bars, this means huge leakage and we cannot pressurize the hydraulic system. Automatically the valve 345, it will be closed and outer pipe also it will be pressurized. Now is the risk that even the outer pipe is leaky to injure the crew member. So inform the crew member that also the outer pipe is pressurized to 200 bar automatic by the engine control system. This it will allow to operate the engine even you are in maneuverance. So if let's assume that you are on Suez Channel and you have increased leakage in some time between the double wall pipe, so you cannot power the mechanical equipment, booster exhaust valve, automatically this one it will be closed to allow you to perform the maneuvering or risk sailing area. Okay. As I told you, we are using to power as a hydraulic oil, lubricating oil, but it's a limited number of the vessel, around 5% from total of the engine delivery. They are using dedicated hydraulic tank. instead of using lube oil as hydraulic oil, the vessel are fitted with a dedicated hydraulic oil tank and feed pumps. This feed pump, it will provide hydraulic oil at the inlet of the filter. Gentlemen, additional cost for dedicated hydraulic oil system doesn't bring some improvement in engine operation. Why? Because mainly the engine operation is affected by the impurities in the hydraulic oil. So even you are using dedicated hydraulic oil or lubricating oil, most important is the quality of the filtration. So improvement was not bring by this additional cost. So around 5% of the vessel are fitted with a dedicated hydraulic oil system. Pumps, normal hydraulic power system supply 95% of vessel are using this setup with 2 startup pump and mechanical driven pump powered by the engine crankshaft. Same, around 5% of the vessel, they are using just electrical driven pump. So the pump are powered not by the engine crankshaft, are powered by increased size of electrical motor. So all the flow it's in the hydraulic system, it will be generated by the pump powered by electrical motors. The advantage is that it's an easy, not easy adjustment, easy procedure to replace, easier access. The disadvantage is that the consumption is coming from auxiliary engine that are powered by just by electrical motor. Of course, you don't have startup pump because all the flow from 0 to 100% engine load is generated by electrical power pump. So you don't have startup pump and mechanical drive pump, just electrical drive pump. But is reduced number of the vessel provided with this system design. Filter, as I told you, 6 micron filter, backwash filter, it will be present to clean, to remove the impurities, a redundant 25 micron filter. Filter usually is displaced, mainly is displaced one platform above hydraulic power supply. Hydraulic power supply is made by third maker parties, not provided by MAN. Startup pump, mechanical driven pump, nitrogen accumulator, 2-bar inlet lubricating oil, high pressure, flexible hoses are used in delivery on delivery side. Filter, manual filter, 25 micron filter, bulkier filter, 6.64, 6.30, it's used same type in fuel oil. So we have the same design like in fuel oil system. The difference is the size, 6.64, in the fuel oil 6.32. One stage is always in standby, the other one in cleaning process. If that one in cleaning process gets clogged, automat, the motor, it will change the position of the valves. The stage in standby, it will go in cleaning process, one of the other one in cleaning process and in standby. Cartridges, there are 2 types, 6 micron or 10 micron. 10 micron, the filtration is not so reliable, but the advantage that can be cleaned by ultrasonic machine. 6 micron sintered cartridge cannot be cleaned by ultrasonic machine. In case they are dirty, you need to replace with a new one. MN is recommended. Mainly you will find this 6 micron. As I said, it's very important, the condition of the cleaning, condition of the lubricating oil. So MN is recommended to use this one, 6 micron sinter filter material. If they are getting dirty, they must be disposed, replaced with the new ones. So filtration process, unfiltered oil is going from outer part of the candles. Impurities remain attached. Clean oil is going toward the pumps. One unit is remaining standby. If the cleaning process is generated either by time interval, which can be adjusted by crew member 30 to 120 minutes, or differential pressure 0.6 bar, the unit from standby, it will go in filtration process. The air, it will be released from inner side of cartridge to one of the stage. Impurities, it will be removed in some tank in the area of the purifier suction. Some change in the design of the sump tank. If the oil is getting contaminated, this area is getting contaminated by impurities, required to remove the oil and to access the sump tank. A change was done by MAN in such a way that in sump tank was introduced this special cylinder where the purifier pipe suction is present and discharged from 50 micron filter, 6 micron filter. If the area is getting contaminated, it's not required to remove the oil, just remove these screws, disconnect the flanges, take out this special cylinder, insert it in the sump tank in such a way to clean, to reduce the workload. You will not be forced to enter in sump tank. Startup pump. Two startup pump are creating initial pressure in hydraulic system powered by electrical motor. The startup pump are axial displacement fixed flow. The pressure in set point pressure can be adjusted by adjusting this relief valve. 200 bar pressure set point, 300 bar system set point pressure for startup pump. The pump, the initial design, the flow delivery by the pump was quite reduced. So in case the mechanical driven pump or gear mechanism suffer a failure between crankshaft pump, we cannot operate the engine just with the flow generated by startup pump. Nowadays, the pump size was increased in such a way even the gear mechanism, the mechanical driven pump suffer a failure to still operate the vessel with limited speed with both startup pump in use. So they deliver enough flow to operate the engine around 15% engine load just by themselves. I will make a note, if you are operating long period engine in low load, this startup pump will run continuously and is the risk to destroy the connection, spider coupling from soft material between the pump and motor. Was several cases when the crew members start the engine, by the connection was destroyed. The motor is turning, but the pump was not providing any flow. So be careful to have always in spare this spider coupling is not a change time interval of this spider coupling in any operating manual. So always try to have this. Otherwise, you will be forced to prepare by yourself because you cannot provide initial pressure in the hydraulic system to start the engine. So you need to have this at least one startup pump in running conditions. So you need to prepare by yourself this spider coupling. Otherwise, there are not so many problems with this startup pump. How the system is working, the startup pump can be controlled in automatic mode. The system can be controlled in automatic mode. So the pump are stopped when the command from engine standby to finish with engine is activated. They start when we are changing the engine state from finish with engine to standby. Both of them are start. The sleeve pump, it will stop when the set point pressure it will be achieved. The master pump when the engine load is reaching 15-17%. Here it's a mistake. It's not RPM which is control the start stop process of the pump. It's engine load, 15 to 17% engine load. If I switch in manual mode, hydraulic, I press this button, I switch manual, I can start stop the pump whenever I want. Engine driven pump, mechanical driven pump, 3 to 5 mechanical driven pump are used to build up hydraulic pressure in the engine. Generally, let's see 2 short movies related to the mechanical driven pump, and after that we'll revert to the presentation. Sorry a moment. I will just run these 2 movies.
An axial piston pump has a number of pistons arranged in a circular array within a housing which is commonly referred to as a cylinder block, rotor or barrel. This cylinder block is driven to rotate about its axis of symmetry by an integral shaft that is, more or less, aligned with pumping pistons, usually in parallel but not necessarily. One end of the cylinder block is flat and wears against a mating surface on a stationary valve plate. The valve plate has two semicircular ports that allow inlet and discharge of the fluid respectively. The pumping pistons protrude from the opposite end of the cylinder block. There are numerous configurations used for the exposed ends of the pistons, but in all cases they bear against a cam. In variable displacement units, the cam is movable and commonly referred to as a swash plate, yoke or hanger. The orientation of the cam, in combination with shaft rotation, provides the cam action that leads to piston reciprocation and thus pumping. The angle between a vector normal to the cam plane and the cylinder block axis of rotation, called the cam angle, is one variable that determines the displacement of the pump or the amount of fluid pumped per shaft revolution. Variable displacement units have the ability to vary the cam angle during operation, whereas fixed displacement units do not. As the cylinder block rotates, the exposed ends of the pistons are constrained to follow the surface of the cam plane. Since the cam plane is at an angle to the axis of rotation, the pistons must reciprocate axially as they precess about the cylinder block axis. During the rising portion of the piston's reciprocation cycle, the piston moves toward the valve plate. Also, during this time, the fluid trap between the buried end of the piston and the valve plate is vented to the pump's discharge port through one of the valve plate's semicircular ports, the discharge port. As the piston moves toward the valve plate, fluid is pushed or displaced through the discharge port of the valve plate. When the piston is at the top of the reciprocation cycle, commonly referred to as top dead center or just TDC, the connection between the trapped fluid chamber and the pump's discharge port is closed. Shortly thereafter, that same chamber becomes open to the pump's inlet port. As the piston continues to precess about the cylinder block axis, it moves away from the valve plate, thereby increasing the volume of the trapped chamber. As this occurs, fluid enters the chamber from the pump's inlet to fill the void. This process continues until the piston reaches the bottom of the reciprocation cycle, commonly referred to as bottom dead center or BDC. At BDC, the connection between the pumping chamber and inlet port is closed. Shortly thereafter, the chamber becomes open to the discharge port again and the pumping cycle starts over. In a variable displacement unit, the cam angle is determining the amount of fluid pumped per shaft revolution. If the cam angle is set to 0, corresponding to that the swash plate is set parallel to the axis of rotation, there is no movement of the pistons in their cylinders. Thus there is no output. If the cam angle is set to maximum, the displaced pump volume and thereby the output will be maximum. If the rotation direction of the pump shaft is reversed with unchanged cam angle, then the pistons will move in the opposite directions, which will reverse their pumping action. This will lead to that the inlet and discharge ports will change place, which means that the flow direction of the pump will be reversed. Some pumps have the ability to move the swash plate over the center position. If this is done at the same time as the pump shaft rotation is reversed, then the piston movement and thereby the flow direction of the pump will remain in the original direction.
Okay, gentlemen, so let's see the other one. I'll try to give some explanation. The pump are axial displacement piston pump. They are common use in all hydraulic systems, especially in Framo system, cargo hedges, steering gear. So we have a pilot valve which is control the swash plate in such a way to control the flow generated by the pump. We can monitor remotely the position of the swash plate, so electrical signal to reach the pilot valve in order to adjust the position of the swash plate, to regulate, to adjust the flow generate. A remote indication of the swash plate position and a local indication. Mainly the pump are made by Bosch Restaurant. Now, multiple piston are translated inside of the cylinder block. The stroke of this multiple piston, they are adjusted by the swash plate. They are adjusted by the electrical signal received from the engine control system. We notice cylinder block, source plate, piston. Now notice by adjusting the cam position related to the axis of rotation, by adjusting the cam angle, the stroke of the piston inside of the cylinder block can be increased, decreased. So the flow generated by the pump can be increased, decreased. Now the piston is travel from BDC to TDC, and it will create pressure in discharge line. Is reaching TDC, the piston, it will be connect this area, that area, it will be connected with suction line, and the lubricating oil, it will be access the cylinder block. Again, the piston is reaching BDC. It will be connected with discharge side of the pump. The piston, it will go in compression stroke. It will create pressure inside of the cylinder block. There are multiple piston which are translating inside of cylinder block. You notice the adjustment of the source plate, the cam angle. It will adjust the flow generating by the pump. Now, gentlemen, let's assume that the engine is turning ahead direction. Now the flow is 0. I increase the angle, cam plate angle. The flow generating, the stroke of the piston, it will be increasing inside of cylinder block, and the flow it will generate. Now let's assume that we reverse the engine. Look what will happen when I reverse the engine. You see the piston which was earlier in compression stroke, they will go in expansion stroke. So the engine reversing is required to interchange the pipe connection, which is physically not possible. I mean, whenever I reverse the engine, to interchange the pipe connection. But let's see, if I change the cam angle toward the axis of rotation, look what is happened. Again, the pipe must be interchanged. So in order to avoid the pipe interchanging, whenever we are reverse the engine, the cam angle, it will be replaced. It will be changed with the electrical signal from engine control system in such a way to not be forced to interchange the pipe connection. So local indication 0 plus 15, 0 not flow, plus 15 full flow ahead, minus 15 degrees local indicator, full flow astern, inductive sensor, which is indicate remotely position of the source plate, and pilot valve, which is receiving electrical signal from auxiliary control unit. in order to control hydraulic oil either on this piston or on this piston to adjust the flow or to reverse the pump cam angle. Now let's revert to our presentation. Gentlemen, I have the pump. How I can adjust the flow? This pilot valve is receiving the electrical signal from auxiliary control unit. I increase the engine speed, engine load. I need to increase the flow generated by the pump. The pressure, hydraulic oil pressure, it will be reduced from this area, and the pressure it will be released on this control piston. So the piston it will move upwards, so it will move the cam angle. The piston stroke it will be increased, the flow it's increasing. I reverse the engine, is required to reverse the source plate angle, cam plate angle. I drain, it will drain this piston, hydraulic oil on this piston, it will be drained. It will be pressurized the top area. The angle plate, it will be reverse related to the axis of rotation. So engine is turning ahead. These pistons from side of the pump are in compression stroke. What is behind are in expansion stroke. Now, gentlemen, if I just reverse the engine, this piston, which earlier was in compression stroke, it will go in expansion. So I need to interchange the pipe connection. Physically, it's not possible. But at what I'll do, at the moment of the engine reversing, the cam angle, it will be also reversed. So the piston, which was earlier in TDC, it will go in BDC. The engine is reversed, so the piston, it will be on the same side of the pump in the compression stroke, like in a head direction. Is it clear?
Yes,
Yes, it's clear.
Okay, gentlemen. Gentlemen, I will ask you to give me 30 minutes break. I have a meeting now for 15 minutes. So 15, 20 minutes. So I will ask you the permission to take 30 minutes a longer break. Okay?
Okay.
Okay. Thank you very much for your understanding. Take 30 minutes break now. Gentlemen, sorry, can you hear me? Are you here? Sorry,
Yes, loud and clear.
sorry, I'm sorry for this delay. It was a long meeting. We have some company technical manager attend to see the training, so we discuss a little bit longer than I expect to discuss. So let's continue further our course. So now we notice that whenever the engine is reversing, the rotation is required. The source plate to reverse the angle, cam plate angle, in order to keep the pipe connection on the same side of the pump. There are multiple type of, or the maker is Bosch Restot, but there are multiple version of the pump. The smaller is delivering 125 cubic centimeter per revolution, while the highest size pump is delivering 700 cubic centimeter per engine revolution. We notice local indicator of the source plate position. So 200 bar system, hydraulic system, the nominal pressure is 210, but for easy identify, the system is named 200 bar. And we have another system, the latest version is 300 bar. Why was increased the pressure, nominal pressure from 200 to 300 bar? If you notice the power generated by the pump, it's equal with the flow multiplied with the pressure. So by reducing the flow, increasing the power to 300 bar from 200 to 300 bar, the power generated by the pump is to remain unchanged. So by reducing the flow, the size of the equipment is reduced, size of the pump, of the actuators. So by reducing the size, the cost in the hydraulic system, it will be reduced. So this was the necessity. This necessity was reduced, was increase the pressure to reduce the size price of the equipment. In this screen, you can see a picture of MOP related to the 200 bar hydraulic system, an additional fourth pump. The fourth pump, it will not modulate the flow. We discussed in first day, the first three mechanical driven pump, they are adjusting their flow based engine low. Pump number 4 and 5, they are delivering full flow ahead or astern, and they are controlled by ECU A and or ECU B, the pump number 5. Indication between the double wall pipe leakage. 300 bar 300 bar hydraulic system, we notice we don't have double wall pipe indication. We have just a single pipe protected by shield galleries, and always just 3 mechanical driven pump. Driven mechanism. The output wheel, the intermediate wheel can be, so the output wheel can be connected with the engine crankshaft either through an intermediate wheel or by a chain. This picture, we have a train wheel, an intermediate wheel and output wheel, nitrogen accumulator, 3 engine axial piston pump with flow controlled by engine control system. Remember, we can operate the engine from 0 to full ahead using just 2 pumps. So the connection between the crankshaft and output wheel through an intermediate wheel. We notice on the crankshaft wheel, we have 2 rows of teeth. In case the inner row of teeth suffer a damage, a failure, we can pressurize, or we can tighten this this nut in this area and to press inside the inner row of teeth and to connect the intermediate wheel with output row of teeth present on the crankshaft. So increase the redundancy even in the connection between the crankshaft and output wheel. Gear ratio is 12 to 1, so 12 times higher speed are turning the pump compared with the crankshaft speed. Another type of connection between the crankshaft output wheel through a chain, double chain 4-inch, same type, 4 inches, same type of the chain, which is used to power the camshaft on the camshaft control engine. And you notice 2 startup pump and mechanical driven pump located on step-up gear, step-up wheel. If the connection is realized through a chain, the hydraulic power supply, it will be located 1 platform above crankshaft. Okay, a intermediate wheel. Step up gear, 12 to 1, same gear ratio. We have gear side, pump side. In case the pump, it will remain stuck, blocked to different reason, mechanical failure. In order to protect the gear mechanism, automatically the shaft connection, this coupling, it will broke in the thinner area. This connection is pre-dimensionated to broke in case the torque it will exceed 25% nominal torque additional on 125% torque. It will be broken in such a way the pump it will be disengaged from gear mechanism to protect the gear mechanism for further powering on remaining good running pump. As I said, to pump can operate the engine from full head to full stern. Some inspection cover in order to inspect the chain or hydraulic system. Okay, this is a picture, Bosch Restrod hydraulic power supply, 2-bar inlet, high pressure flexible hoses. Filter located one platform above hydraulic power supply. Startup pump. The valve block 310, 311, we'll discuss later. For large size engine, you notice the hydraulic power supply is located in the middle of the engine with the roll to reduce the torsional vibration of the crankshaft. It will be located in the middle of the engine. The pump are displayed on both sides of step-up wheel. Gentlemen, mainly you will not perform overhauling of pump on board of vessel. It's exchange-based procedure. Every 5 years, every dry dock, you will send the pump for overhauling to MAN or Bosch Restrod, and you receive reconditionated pump. What you'll do, you'll change the pilot valve. Sometimes the pilot valve, the coil is burned out, it's broken, or the feedback sensor can be out of order. So you replace this equipment. Whatever, if you replace the pump, you notice these two pumps have the same control principle of the source plate, but different than this one. So you can interchange this pipe, but you cannot interchange these two pipes. So always mark the position of the pump at the disconnection from gear mechanism. The system, hydraulic power supply system, was improved. The design was improved in such a way to make more reliable. The first design, they used the metal pipe. Latest version, they are using rubber flexible hoses between the pump double wall pipe. So we notice now in this area we have the pump, in this area double wall pipe connection with flexible rubber hoses. Life expectation of the flexible rubber hose is 5 years from the date of the manufacturer. So you keep 5 years in spare, and now you want to install. They are not more recommended by MAN to be installed. So 5 years from date of the manufacturer life expectation. Also, some changes taking place in position of the valve, position of the pump, in order to make them easy accessible by the crew member to be replaced, marked for latest version or in the hydraulic power supply. Okay, so you can access the system in order to monitor the position of the source plate to inspect for any leakage present in the area. As I said, hydraulic power supply is made by third party, is ready to be attached, to be connected with the gear mechanism to install on the engine. 200 bar system, hydraulic power supply system. From the system, hydraulic oil is delivery. This is 300 bar system. From the hydraulic power system, the hydraulic oil is delivered to a common pipe. This is a common pipe. From the common pipe, hydraulic oil is delivered to each hydraulic cylinder unit through a flexible hoses. In 200 bar, we have double wall pipe connection between the hydraulic cylinder units in this area. So this is 300 bar hydraulic oil system. Control principle. We notice we have two startup pump, 3 mechanical driven pump. Gentlemen, the 3 mechanical driven pump have different running mode. One of the pump, so the pump number 1 in this case, it's operating in pressure control mode. The other two pump are operating in follower mode. You notice this abbreviation, control mode, follower mode. What is the difference? The control pump is running always the control pump is delivering always 50% flow. In case the engine load is increased, decrease, it will react immediately to compensate this deviation between the actual pressure and set point pressure. Over the time, the lower pump, it will adjust this deviation, it will compensate this deviation, while the control pump, it will goes back to 50%. So control pump always, it will deliver 50% flow. We can select the control pump between these three whenever we want by selecting the pump and select as control pump. In case the control pump, it will suffer a failure, automatic when the other pump, it will take over the control of the, it will run in control mode. By pressing hydraulic power system and operate in manual mode, the set point pressure, it will be must be set by the crew member. So the set point pressure always is adjusted by the estimated engine, based on the estimated engine load automatically. But if we select manual mode, the set point pressure must be set by the crew member. So you don't have any reason to keep the system in manual mode if everything is normal. Gentlemen, if we have a mechanical failure of a pump, we discussed that this pump, it will be automatically disconnected from gear mechanism by broken the shaft coupling. But in case of control failure of a pump, the source plate, it will be forced to maximum capacity ahead direction. So what is this tendency? If we are losing the MPC, auxiliary control unit, the pump number 1 is controlled by auxiliary control unit number 1, number 2 by auxiliary control unit number 2, pump number 3 by auxiliary control unit number 3. So in case on one of the auxiliary control unit, it will suffer a failure, automatic that pump, it will go in safe mode. It will goes to delivery full flow ahead engine direction. What this means? Electrical signal. We can lose MPC or pilot valve or feedback sensor. If any electrical equipment of the pump suffer a failure, the pump, it will goes in safe mode. It will deliver full flow ahead engine running. So let's simulate this one. I'll access on the auxiliary menu. We have scavenger. We discussed on. We have scavenger was discussed by us in the first day, and hydraulic system. To start a pump, both of them are stopped. The engine load is above 15%. One pump is in control mode, the other two in follower. I select the pump number 2 in control mode. You will see that the pump number 2, it will deliver 50%. The other two, it will adjust the actual hydraulic pressure toward the set point pressure. Now, as I said, if one of the pump, it will suffer electrical control failure, automatically the source plate of that pump, it will goes to delivery full flow ahead engine running. Wait a while, I increase a little bit the engine load. Let's wait to stabilize the hydraulic system to goes to 50%, and we'll discuss after stabilizing the system to have a steady engine load. Okay, I will simulate a failure of the electrical failure of pump number 2. So let's see what will happen. So I simulate a failure of the auxiliary control number 2. You notice the pump automatically, the pump number 2 is in control mode. One of the other pump, it will take over the control of the system. And the respective pump, which lose his electrical control, it will goes to safe mode. It will deliver 100% full flow ahead engine running, and it's in fail. Now I will stop the engine. You notice that the control pump, it will try to goes to 50%. This one, it will deliver 100%, while the follower, it will try to adjust the actual pressure toward the set point pressure. Sorry, gentlemen. I will stop the engine now. and I will reverse the engine. Wait a while to stop the engine. Let's wait to stop and I will reverse. Wait a moment. Okay, let's reverse now. The engine is stopped. Let's reverse. Gentlemen, we discussed until now, if we reverse the engine, the pump must reverse their south plate. Otherwise, we need to interchange the pipe connection because the piston, which was earlier in compression stroke, it will go in expansion. So we need to interchange the pipe connection. In order to not interchange the pipe connection, we reverse the angle of the south plate. But let's see what will happen. What was happen now? Engine is turning minus 60 revolution. Let's see what was happen with the pump, which lose her electrical signal, his electrical signal. You notice these two pumps reverse their south plate, while the pump, which is not electrical control, is remain to deliver full flow ahead engine running. So where, from which side of the pump it will take place the suction now? Which will be the suction side of the pump now? So the suction, it will be from this area, yes? The pump doesn't reverse the south plate. You notice this is minus. So the pump, it will have the suction from the discharge line. Gentlemen, we cannot allow the pump to have the suction from discharge line because we cannot pressurize the system. In the respect of this, you will find this no return valve installed.
Oh, yes, non-return valve.
No return valve installed. But now the pump is still connected to the engine crankshaft. Yes? If the pump is turning as is connected by the engine crankshaft without inlet lube oil, it will lead to the mechanical failure, to the dry contact between the mechanical equipment. So it will lead to the failure. How we can protect this engine? So maybe we have a MPC failure, and now I will destroy also the pump do this MPC failure. So we have any way to protect the pump? You see through the pump, we have this small connection. So now the suction is in this area. We have this no return valve, but is required to lubricate the pump as is still powered by the engine crankshaft. And now through the pump, we have this small orifice, which will allow two-bar inlet pressure to reach discharge line. The pump, it will have a suction from this area, and it will discharge the pressure back in the suction line, and it will recirculate a small quantity of the oil to be lubricated.
Or just to lubricate the pump,
yes,
correct?
Just to be lubricated, yes. A small quantity. If you notice the pipe connection, the orifice is quite small, and it will be used just for lubrication of the pump in case it will lose the electrical signal and we reverse the engine. Clear?
Clear.
Good. Okay, I will stop now the engine and I will reset the pump. Okay, I will remove the simulation and I will wait to stop the engine. Okay, to reset the pump, maybe electrical signal, we just press the pump and press reset. I will start the engine ahead. Wait a while to reset the pump and I will start the engine ahead. We'll discuss other things. We notice the valve, relief valve 310, 311. In case the pressure is exceeding the maximum 315, this one it will open, or 310 bars, this valve it will open. So 310 valve, it will open a 310 bar, 311 a 315 1.5 bar. Okay, I will order the engine to run a little bit with higher speed. Wait a while. Okay, gentlemen, if you notice now, the engine speed is 85 revolution. Okay. I will simulate a blackout in this moment with this engine speed. I will simulate a blackout on our engine, on our vessel, to see what will happen in this case. Okay. Gentlemen, we notice with the blackout, a shutdown, it will activate. What is happening in the blackout? Inlet lube oil pressure, it will get zero. Why? Because the main lube oil pump are powered by electrical motor, so we will not have any inlet lube oil pressure. But if you notice, if we have blackout, the engine will still turn. Actual engine speed is 44 revolution. The engine will be still turn because we have some inertia of the vessel which will power the propeller. Propeller, it will turn further the crankshaft and will turn the engine. Yes. So this is the real action. Now, if the crankshaft is turning with 40 revolution, if we multiply 40 with 12 gear ratio, the speed of the pump, revolution of the pump, it's 440 revolution. So the pump are turning with 440 revolution. If I am not able to restore the power supply, electrical power supply to the pump, main lube oil pump, probably in 20 minutes running of the pump with higher speed, I will destroy, as the pump, it will not be lubricated. So I will protect the pump if the inlet lube oil pressure, it will goes lower than 0.5 bar. How will protect this pump? The low lube oil inlet pressure and the engine is still turning. So in our case, you notice the engine is turning to the blackout without lubrication. How we can protect this pump? The valve 310 have double role, is opening in case of higher pressure to protect against higher pressure. Relief is function as relief valve, but you notice the valve is open when the inlet lube oil pressure, it will go lower than 0.5 bar, the valve it will open. So the valve is open and it will recirculate the oil between discharge line, suction line. If you notice, even the inlet pressure is 0 bar, discharge pressure is 160 bar. Okay, so the oil will be recirculated in order to protect the pump over the dry running in case the lube oil pressure it will go lower than 0.5 bar. Is it clear?
Here.
Good. Now I will restore normal operation of the engine. So I remove the blackout. I will simulate the blackout removed. And I will reset low lube oil. Pressure is 2.5. Automatic, the valve 310 is closing in order to allow me to pressurize hydraulic system. Clear? Then I have a recommendation to test this valve 310 at each 3 months. How we are testing this valve? With the engine in stop condition, allow just one startup pump in running. So select the hydraulic power system in manual mode. Allow just one pump, startup pump in running. I stop one of the startup pump. Okay. The system in manual mode is, sorry, the system is in manual mode. Now you will open, because you see this this valve 310 is protecting just the mechanical driven pump. Now the pressure is coming, the engine is in stop condition. The pressure 224 bars is coming from startup pump, from this startup pump. The engine is stopped. So the pressure from the startup pump must reach the valve 310. We have this no-return valve. In order to bypass this no-return valve, we are opening the valve 316. So I open the valve 316, manual valve 316, and now the pressure with the engine in stop condition, 224 bar, it will be available also at the valve 310. So how we are testing the valve? By pressing this button, I notice that additional 2 buttons are available on the MOP. Physically, there are 2 valves. Same on your MOP, on your engine, you see just 1 valve, but physically local are 2. One of the valve is controlled by auxiliary control unit number 1. The other valve is controlled by auxiliary control unit number 2. How you test now the system? Choose one of the valve, press open. You press open. The valve, you show that is showing open. Wait for the pressure to start to be reduced. When the pressure is reaching around 20 bars, you understand that the valve is physically open and it will protect the pumps in case low lube oil pressure. I will press close the valve. Now the pressure on my engine is not dropping because physically I cannot open the valve 316. So I press close, the valve is closing, closing, and I will evaluate the build-up pressure in the hydraulic system. If the system doesn't have leakage and startup pump number 1 is operating properly, the pressure must reach set point level in less than 120 seconds, so less than 2 minutes. I will repeat the same procedure, but now testing the valve 310 controlled by auxiliary control number 3. I will stop the startup pump number 1. I will start number 2. The valve 316, it's open. I select the valve 310 and I press open. Now I evaluate the pressure to be dropped. So through this bypass valve, the pressure it will drop. Now, gentlemen, when the pressure is reaching around 20 bars, this means the valve was opening. It will protect the pump during low risk of low lube oil pressure. I will press close. The valve it will close, and now I check again the build time of the hydraulic pressure in hydraulic system to be less than 120 seconds. If it will happen, also the pump number 2, startup pump, is in good running condition. After I complete the test, I close the valve 316 and I switch in automatic mode the control of the hydraulic power supply. Pumps number 1, 2, 3, they have their own sensor for system pressure, connect their auxiliary control unit, we discuss. Pump number 4 and 5 are controlled by binary signal. They are delivery full flow ahead or astern engine running. Pump number 4 is controlled by ECUA, number 5 by ECUB. They can be found just in 200 bar system and in large size engine. All pumps have sensor for suction pressure. If the pressure is too low or all sensors are falling, a shutdown, it will be activated. We discuss shutdown, it will activate. Also the valve 310, it will open in order to protect against dry running of the pump. Wait a while, I need to leave the selector. Okay. Gentlemen, as I said, whenever we are replacing any mechanical equipment with a new one, is required to perform a procedure named function test in order to see if the new equipment is operating properly. So in case I replace mechanical driven pump or associated equipment like feedback sensor or pilot valve, pilot control valve, is required to perform function test procedure for that new pump. Where I found this function test procedure? In maintenance menu. Function test. What I am testing? I am testing hydraulic system. So I choose hydraulic power supply, and now I can perform the procedure to all of the pump one by one. But let's assume that I replace the mechanical driven pump number 3. I choose pump number 3. Let's see the procedure. Same like in Tahoe system, we are following the procedure from MOP. We press start button, start one of the hydraulic power supply, start a pump in local control. So I go in the engine room, I switch start a pump, electrical driven pump number 1, start in local mode, and I confirm by pressing that. An assistant is standing by viewing the source plate changes. So I send one of the crew member near mechanical driven pump number 3 local indicator to evaluate the changing on the source plate, minus 15 degrees, full astern, plus 15 degrees, full ahead source plate. So I confirm when the crew member is reaching the mechanical driven pump number 3. I will start the test by pressing start, set the auxiliary control unit 3 into test mode. I press reboot button in order to change in test mode. It takes around 2-3 minutes to change in test mode. Several alarms will activate. Disregard this alarm as the engine is in stop. We just complete the mechanical work. Okay. Okay, still the circle is turning, so let's wait until it will complete turning in order to be confident that the booting process is complete. So now you notice that circle is complete turning. So now, gentlemen, for new installed pump, I will order with the electrical signal from auxiliary control unit number 3 to move the source plate to full ahead. In order the source plate to reach full ahead, I need to have a remotely indication from feedback sensor, a value between 12 to 20 milliamps, and local indication must be plus 15 degrees. I press OK button, and let's see what is the position of the source plate remotely. Now you notice the test value is 19 milliamps. For full ahead, the feedback must give a reading 12 to 20. I have 90, which is within the reference area. I cross-check with the local crew member if the source plate is plus 15 degrees. If it's plus 15 degrees, this means that the new pump which I installed is operating properly. Order the source plate to full astern. I press OK. Let's see if the pump is reversing the source plate. I notice now the feedback, it's indicate a value 6.1 milliamps, which is inside of the reference area 4 to 12 milliamps. So the pump was also reverse. I cross-check with the crew member, local indication must be -15. If everything goes okay, I press save. So I save, I calibrate full ahead, full astern of the pump with the engine control system. This it will be new reading position for full ahead, full astern, surge plate position, and I press save. If during the test something was the test value was different than reference value, this means something was wrong, abnormal, pilot valve, pump, feedback sensor, and I press abort test. If I test just to see how it's operating the equipment which is in use, I press skip. So I press skip. I'll perform the test again. Set auxiliary control in test mode. It's already in test mode. I'll press reboot just to access next step. Order the surge plate to full ahead. I'll order to full ahead. Let's see what will happen. Order the surge plate to full astern. Now I order to full astern. Gentlemen, can you help me to investigate what is wrong with this pump? Who can help me? Prashad, can you help me? So what is wrong? So I order the pump to go to full astern. What I identify remotely? The feedback it's outside of the reference, yes?
Yes.
So the pump doesn't reverse. Gentlemen, I go local and I check local the position of the surge plate. If the local, its indication is -15 degrees, this means that the pump was reversed. Where is the problem? Where is the problem, gentlemen? Come on, Nikolai, Kenan, where is the problem?
In the feedback.
Right, in the feedback sensor.
Device with feedback, yeah, correct.
I replace the feedback sensor. I press abort test, and I perform again the test. If after I replace the feedback sensor, everything is okay, I save. But if even local doesn't show -15, this means that actual, remotely, and local, the pump doesn't reverse. I have also local cross check. The pump doesn't reverse, so the reason could be the pilot valve. So maybe the coil of the pilot valve is broken, or the orifices in the pilot valve are clogged with impurities from hydraulic oil. So I replace the pilot valve. And I perform again the test. If I have the same problem after I replace the pilot valve, this means that I have a mechanical problem with the pump. It's a real mechanical. It's a mechanical problem with the pump. The pump is stuck in a certain position and is not changing the surge plate. So I have a stuck pump. But as I said, it's less probable to have any mechanical problem with the pump. Mainly the problem is either with the feedback sensor or with the pilot valve. Now you can identify easily if it's a pilot valve or feedback sensor. So generally the function test procedure is the procedure to test and to calibrate the operation of the pump with the engine control system. In troubleshooting menu, we have another procedure which will help us easy to identify if we have a problem with any mechanical equipment. We discuss, or electronic equipment, discuss isolation. If I access hydraulic power system, I can perform a function or troubleshooting procedure for all 3 mechanical driven pump. I choose the pump number 3. Why? Because the MPC it's already in test mode to save some time. You notice channel 70 from auxiliary control in number 3, it's electrical signal to adjust the surge plate. Channel 34 is feedback from remote from inductive sensor to the auxiliary control unit number 3 to identify position of the source plate if it's reacting well or not according to the signal sent. Now I have some arrows which will allow me to set different position of the source plate. I want the source plate to change to 66% ahead. And I press set. Please monitor electrical signal and feedback position. Electrical signal was changed in order to send signal to source plate, to the pilot valve. And now, wait a minute. Okay, sorry a little bit because I forgot my simulation from previous. So now you notice I can see remotely indication 66%. I go local 66% ahead. Local must be around plus 10 degrees. If it's plus 10 degrees, this means everything is okay. I said I want to test if the pump is reversing. I set 33% a stir. And I press set. Please monitor electrical signal and remote sensor. I notice that the remote sensor is showing that the pump is reversed. I go local, minus 33%, must be local around minus 5 degrees. If it's 5 degrees, this means that this pump is operating properly. After I perform the test, do not forget to switch back in normal. So the troubleshooting is fast. Test of the mechanical equipment installed on the engine to see if they are still operating properly. If I set different position, local, it's according to my desire, according to my designation. Remotely is not. The feedback sensor is with the problem. If I set a position remotely and local, the position set is not achieved, I have a problem with a pilot valve. I replace the pilot valve, function test, and save the test. Two sensors are located below hydraulic power system on a drain pipe to evaluate condition of possible condition of the leakage. So on a drain pipe located below hydraulic power supply, we have a drain box in which two vibrating sensors are located. The lower level sensor, it will activate an alarm in an engine control system. The higher level sensor, it will activate a shutdown. So if the lower sensor, it will give alarm, be prepared to have a shutdown. But this shutdown is cancelable. If you are sailing in risk area, you can cancel this shutdown in order to avoid any incident with your vessel. A picture from 200 bar system, nitrogen accumulator, pumps, crankshaft. Sensor, nothing to discuss. Components, pilot valve, which is receiving the electrical signal to control hydraulic wheel to adjust the source plate. Feedback sensor, which is monitor position of the source plate. Electrical driven pump. 5% of the vessel, they are fitted with pump powered by the electrical motor. Advantage is the easy dismantling and mantling on the engine. The disadvantage is that always is required to have a reserve of electrical power supply in main switchboard in order to cover suddenly electrical power asking by this pump at the starting. But they are operating, they have also different operating principle. Is not a pump in control mode and other pump in follower mode. The pump are sharing equal their flow. If two pumps are running and the source plate, the flow is reaching 90%, automatically the third one, it will start and they will share equal the flow. If I have 4 pumps installed on the engine, the 3 pumps are modulating their flow. The pump number 4 is delivering always full flow. So this pump is not reversing because they are powered by the electrical motor. In case the pump which are modulating the flow, they'll deliver less than 50%. The 4th pump, it will stop. The remaining pump, it will share equal the flow. Valve block, there are two valves, position 310, 311, with the purpose to protect the system over the pressure. The valve 310 have double role, also to open this one, 310, to open in case low lube oil inlet pressure to protect the pump over the dry running. The valve 310, it's opening at 230 bar in 200 bar system or 310 bar in 300 bar system. The valve 311, this one, it's opening at 250 bar or 315, depend the system, hydraulic system installed on the engine. Gentlemen, do you have any questions?
Not for the moment.
Kenan, question. Nikolai, questions?
No, the same, for the moment, no questions.
Okay, gentlemen, we can complete the course for today. We continue tomorrow with the hydraulic cylinder unit, okay?
Okay, have a
I
nice
have,
day.
please, sorry. I have a question to you. Please send to our email a picture with you, and the name how you want to appear on certificate. Okay, we need to prepare your certificates. So I need a picture of each of you, passport or ID size, picture, ID size, and the name how you want to be typing on your certificate. Now, two of gentlemen are coming from Oldendorf. Nikolai, which is your company?
Oh,
Nicola?
my Optra.
Oldendorf, which is your company?
Optra.
I don't
My
know.
company is Optra.
Uh,
Scorpio Group.
okay. So for you, please send also phone number because we need to send to your home address certificate. For the gentleman from Oldendorf, we send to the main office. But for you, Nikolai, we will send the hard copy of your certificate to your home address. So I need picture, name, phone number, home address, postal code from you, just from you.
Okay.
Name, picture, postal code, home address, phone number. That's it. Okay, gentlemen. See you tomorrow, 8:30 East European time. Clear? Same
Okay.
time like today.
Okay.
Okay, see you tomorrow.
Okay. Enjoy your afternoon. Bye-bye.
Okay, see you tomorrow.
Bye-bye.